Welcome back, guys. In this lecture, we want to look at the terminologies used in the study of a periodic table. Actually, there are just three of them, very direct and very straightforward. So we'll run through these terminologies if we have enough time in this video, but if we don't, it means we'll have to cut it to the next video. There are three terminologies we need to be very familiar with if we are studying the periodic table. And these terminologies include 1. Groups, 2. Periods, and 3. Blocks. Alright? So we need to know what a group means when studying the periodic table. We need to know what a period is. And finally, we need to know what a block is. So what is a group? A group is the vertical column you see on the periodic table. The vertical columns containing elements in the periodic table. So when you look at the periodic table, you see those vertical columns running from 1 up to 0. Alright, each of those columns is called a group. Alright, and it didn't just come about. There is a factor we consider before we put elements into the same groups. Now, elements in the same groups share something in common, which is the number of outermost electrons. So elements in the same group have the same number of outermost. It's very important, guys, do not forget that elements in the same groups are put there because they have the same number of outermost electrons. And the number of outermost electrons an element has tells you the group it belongs. So if an atom has 2 outermost electrons, it means it belongs to group 2 of the periodic table. If it has 7 outermost electrons, it means it belongs to group 7 of the periodic table. If it has 1 outermost electron, it means it belongs to group 1 of the periodic table. And that's how elements are grouped into the periodic table. Okay? Next is the period. The period of an atom, or the period of the periodic table, is at the horizontal rows that are seen on the in the periodic table. The horizontal rows seen in the periodic table are what we call periods. So in the periodic table we have 7 periods. The first 4 of them, or the first 3 of them are short periods, and the next 4 are long periods. What we mean is, the first 3 of them do not run completely from left to right. There is an intersection in between. But from period 4 to period 7, you have a complete run from the first to the last. And how are elements put in the same period? Elements are put in the same period if they have the same number of electronic shells. So if elements have the same number of electronic shells, then they belong to the same period. There are 7 periods in the periodic table. And finally, we have blocks. Blocks are suborbitals where the last electrons or the outermost electrons of an atom fits. So when you take the electronic configuration of an atom, alright, you distribute the electron of an atom into suborbitals. The very last suborbital where you have the outermost electron of the atom tells you the block of the atom. In the periodic table, groups 1 and 2 elements are S block. Groups 3 to 0 elements are P block. The transition metals, which are between groups 1A to which are between groups 1B to 8B, are D block elements. While the lanthanides and actinides, we'll talk about all these in details, but the lanthanides and actinides are F blocks. So there are just 4 blocks in the periodic table: S block, P block, D block, and F block. And these blocks are generated from the suborbitals we have. The suborbital was given to us by Pauli, by Pauli when he studied this Pauli's exclusion principle. And we understood what suborbitals were. We have the S, P, D, and F suborbitals, right? Alright, so elements in the periodic table can belong to a group, a certain period, and a certain block. So we'll look at how to determine what group and period and block an atom belongs. But before we do that, let us state the unique features of atoms to fit into these categories. Atoms in the same group, alright, atoms in the same group have the same number of valence electrons. I can't emphasize this enough. They have the same number of valence electrons. But atoms in the same period have the same number of electronic shells. What the block of an element really is, in the periodic table, groups 1 and 2 are S block. Groups 3 to 8 or to 0, okay, let's leave it that way, are P block. Groups 1B to 8B. All these are A. So this is 1A, 2A, 3A, 8A, right? So 1B to 8B are transition metals. Please don't be cracked up about this. Don't be pissed off. We'll talk about every one of them in details. While lanthanides and actinides, the lanthanides and actinides are F block. Sorry, response of which are transition elements are D block. So they are D block elements, and that is how we classify elements into these categories. So if you're given an element and you're asked to determine the group, its period and its block, how do you do that? How do you tell us the group of an element? How do you tell us the period it belongs? And how do you tell us the block it belongs? Guys, join us in the next lecture when we take a couple of examples on determination of the groups, period, and block of atoms. Thanks for sticking with us. See you in the next lecture.